Well, today we're going to talk more about circles, but this time we're going to get out of the coordinate plane and we're just going to talk about the shape that is a circle. So today we're going to talk mostly about arcs and angles that we can create in circles. And an arc is just a piece of this circle. So the arc of the entire circle is 360 degrees. So the entire measure around this circle is 360 degrees. You might already know that. So then if we start cutting the circle into smaller pieces, we get smaller arcs. And one special arc would be a semicircle. That's half of a circle. Semicircle is 180 degrees. And it's created by any diameter. So a diameter goes through the center of the circle and starts and ends on the circle like this purple or pink line. So this cuts the circle in half and creates a semicircle. So each of these halves, the green one and the yellow one, are both 180 degrees. So we can have angles formed inside of circles, just like this one right here that I've represented. This one has its vertex at the center of the circle. So it's important to note that this is the center of the circle. When I have that existing, I have what's called a central angle, and we have a relationship between this angle that I showed you in red and also the arc that it creates. So this angle and these sides of the angle create this yellow arc, and the relationship is that the measure of the angle is equal to the measure of the arc. So if the angle is 80 degrees, the arc is 80 degrees. If the angle is 90 degrees, the arc is 90 degrees. So if we see a central angle and we have some expressions and some measures, we can do some setting up of equations and solving using the relationship that the angle is the same size as the arc it creates. So I have this angle of 104 degrees, and it creates this arc right here. And I've told you the arc is 6x plus 14 degrees. So I can use the relationship that the angle is equal to the arc. And then I can plug in the information I know. The angle is 104, the arc is 6x plus 14. And then it's just back to algebra like we've been doing all year. And if we were to plug 15 in here for x, we would find that 6x, or 6 times 15 plus 14, is equal to 104. So we'll try this one. I have an arc of 88, and I have an angle here that is 9x minus 2 degrees. Since the angle has its center, or has its vertex at the center of the circle, then I can use this relationship that the angle is equal to the arc. So I plug in the information I know, and now I'm off doing some algebra to find out that the value of x is 10. So pause here and use what you just learned, what we just practiced, and find x. So I have an arc that's 13x minus 5. And I have this angle here that's centered at the, or that has its vertex at the center of the circle. The angle is 73 degrees. So these two things should be equal to each other. I write the relationship every time. This way I can establish the relationship in my mind, plug in what I know, and make sure I do my algebra correctly to get that x is 6. So I'm always going to continue to say you need to write the formula, you need to write the relationship every single time, and it'll start being imprinted in your brain. Another special type of angle that we have formed inside of circles is what's called an inscribed angle. I hope that you notice that this time the vertex is on the circle, it's not at the center. So I have this angle created where my vertex is on the circle. We call that an inscribed angle. And there's a special relationship that exists here. So this angle creates an arc, just like our central angle did. The relationship is a little bit different. The angle is equal to the arc measure divided by 2. So if I know the arc measure, I can divide it by 2 and it'll tell me how big that inscribed angle is. So let's try one using that relationship. I have an angle right here that's 35 degrees, and my arc, which is the piece of the circle, is 8x minus 10. So I need to start with the relationship for an inscribed angle. I'll plug in 35 for the angle and 8x minus 10 for the arc. And now we have something that sort of looks like something we had way back in our review lesson 0. We got to multiply by 2 on both sides to get rid of that 2 in the denominator. And now we have an equation that we can just solve for x and get that x is 10. So you see how when you multiply this 35 by 2, you get 70. That's because this arc is actually 70 degrees. It's twice as big as the angle, and the angle is half as big as the arc. So if we look at this problem, the angle is 40 degrees. That means, and it's also an inscribed angle, it's half of whatever this arc is. So if this angle is 40, we know that the arc has to be 80. But that's not what we're looking for. We're looking for x in this case. So we'll use the formula, or the relationship, and we'll plug in what we know. Multiply both sides by 2, and you'll see over here on the left, I got 80. That's because this arc is 80 degrees. It's twice as big as the angle. The angle is half as big as the arc. But still, we're going to use this to find x by doing some algebra, and get that x is 5. So pause here. I've given you an angle and an arc, and I want you to use what we just practiced in the last 2 slides and find the value of x. So again, I have the measure of an inscribed angle. Its vertex is on the circle. It creates this nice big arc, this part of the circle out here that we called 7x plus 5. So we have our relationship. Write it down every time, and it'll imprint in your brain. Plug in what we know. The arc is 2 times as big as the angle. The angle is half as big as the arc. So this arc is actually 194 degrees, and we see that when we multiply both sides by 2 in this equation. And then if we solve correctly, we should find that x is 27. So I have one of each here for you, 2 you-do problems. Find the value of x for both of them. Click the link below this video. Submit your answers on the you-do form. And if you have questions or concerns, we can talk about them in class.